The James Webb Space Telescope has just unleashed a discovery so staggering, so utterly mind-bending, that it's sending shockwaves through the very foundations of cosmology. You've probably heard whispers about how this incredible telescope has been shaking things up, spotting massive galaxies in the early universe that defy everything we thought we knew about how the cosmos came to be. But hold on to your seats, because the latest revelation is far more explosive. It's not just about galaxies forming too fast or too big, it's about the cosmic microwave background, the CMB, the so-called fossil light of the Big Bang itself. For decades, scientists have pointed to this faint glow as the ultimate proof of the universe's fiery birth. But what if we've been wrong? What if this sacred signal, the cornerstone of modern cosmology, isn't what we thought it was? New research from May 2025, based on jaw-dropping observations from the James Webb Space Telescope, suggests that the CMB might not be the pristine echo of the Big Bang after all. Instead, it could be something else entirely, something that could unravel the very story of how our universe began. Picture this: the universe, just a few 100 million years old, a cosmic infant barely out of its cradle. According to the standard model of cosmology, this was a time when the universe was still cooling, still forming its first stars and galaxies in a slow, gradual process. Tiny clumps of matter were supposed to merge over billions of years, building the massive galaxies we see today. But the James Webb Space Telescope has turned that idea on its head. It's found galaxies, enormous, fully formed galaxies, existing at redshifts greater than 13. That's just 300 to 400 million years after the supposed Big Bang. These aren't baby galaxies, they're cosmic titans packed with stars, glowing with an intensity that defies every prediction. How could such massive structures form so quickly? It's as if the universe hit the fast-forward button, churning out galaxies at a pace that makes our current models look like they're stuck in slow motion. These early-type galaxies, as astronomers call them, are a special breed. They're not like the star-forming powerhouses we see in the nearby universe. These are quiet giants, filled with old stars that have already burned through their prime. Normally, we'd expect to find such galaxies much later in cosmic history, after billions of years of evolution. Yet here they are, staring back at us from the dawn of time, challenging everything we thought we knew. The discovery of these galaxies is already a cosmic bombshell, but it's what they imply about the CMB that's truly earth-shattering. The researchers behind this new study propose a radical idea. The radiation from these massive early galaxies could be masquerading as the CMB. Yes, you heard that right. The signal we've been studying for decades, the one we've hailed as the ultimate evidence of the Big Bang, might actually be the combined glow of billions of these ancient galaxies, stretched and redshifted by the universe's expansion until it mimics the CMB's signature. Let's break this down. Imagine a universe teeming with these massive galaxies, each one bursting with young, hot stars pumping out intense radiation. If enough of these galaxies were scattered across the early cosmos, their collective light would have filled space with a powerful glow. Over billions of years, as the universe expanded, this light would stretch, its wavelengths shifting from ultraviolet and visible light into the microwave range. By the time it reaches our telescopes today, it looks eerily similar to the CMB, a uniform, faint hum that blankets the entire sky. The researchers estimate that the radiation from these early galaxies could account for at least 1.4% of the CMB's total energy. That might sound small, but in the world of precision cosmology, it's a game changer. And here's the kicker. That's a conservative estimate. If we factor in all types of early galaxies, not just the early type ones, that percentage could climb even higher, potentially dominating the CMB signal. Now let's pause for a moment to let the weight of this sink in. The CMB has been the bedrock of the Big Bang theory since it was first detected in 1965. It's the snapshot of the universe at its earliest moments, a faint glow from when the cosmos was just 380,000 years old, still hot and dense from its explosive birth. Scientists have used its tiny temperature fluctuations to map the universe's early conditions, to calculate its age, and to estimate how fast it's expanding today. But if this new research is correct, we might not be looking at a pure signal from the Big Bang. Instead, we could be seeing a cosmic mirage, a mix of light from the Big Bang and the radiation from these unexpectedly massive galaxies. If that's true, then the CMB isn't the pristine relic we thought it was, and everything we've built on it, our estimates of the universe's age, its expansion rate, even the physics of the early cosmos, could be called into question. This isn't just a minor tweak to our understanding. It's a potential paradigm shift. The CMB has been the gold standard for cosmology, the one piece of evidence that tied everything together. It's been used to support the idea that the universe began with a rapid expansion, inflating from a hot, dense state to the vast cosmos we see today. But if a significant chunk of the CMB's signal comes from early galaxies, then the patterns we've been studying, the ones we thought traced the universe's first moments, might be contaminated. Those tiny ripples in the cosmic microwave background, which we've used to rewind the cosmic clock, could be distorted by the glow of these ancient galaxies. And if that's the case, our calculations of the universe's expansion rate, known as the Hubble constant, could be off, possibly by a lot. Speaking of the Hubble constant, this discovery ties directly into another cosmic mystery that's been baffling scientists for years: the Hubble tension. For those who haven't heard of it, the Hubble tension is the frustrating mismatch between two ways of measuring how fast the universe is expanding. One method uses the CMB, analyzing its patterns to estimate the expansion rate in the early universe and then extrapolating to today. This gives a value of about 67.4 kilometers per second per megaparsec. The other method looks at nearby galaxies and supernovae, measuring their distances and speeds directly. This approach consistently yields a higher value, around 73 kilometers per second per megaparsec. That discrepancy, about 8%, is too large to be explained by measurement errors alone, and it's been driving cosmologists up the wall. Could this new discovery about the CMB be the key to solving the Hubble tension? If the CMB signal is partly or even mostly from early galaxies, then the expansion rate we've calculated from it might be wrong. That would explain why it doesn't match the measurements from nearby galaxies. It's like we've been reading the wrong map all along. And now, the James Webb Space Telescope is showing us the real terrain. But the shocks don't stop there. These early galaxies aren't just challenging the CMB, they're forcing us to rethink how the universe evolved. According to the Standard Model, galaxies formed slowly, starting as small clumps of gas that merged over billions of years to create the massive structures we see today. But the James Webb Space Telescope is showing us galaxies that were already huge and complex just 300 million years after the Big Bang. That's not just fast. It's practically instantaneous in cosmic terms. It's as if the universe went from a blank canvas to a masterpiece in the blink of an eye. How could so many stars form so quickly? What kind of physics allowed these galaxies to assemble at such a breakneck pace? The researchers suggest that the early universe might have been much denser than we thought, allowing stars and galaxies to form in a burst-like frenzy rather than a slow build-up. If that's true, it could mean that the conditions of the early cosmos were wildly different from what our models predict. This discovery also raises questions about dark energy, the mysterious force driving the universe's accelerating expansion. For years, scientists assumed dark energy was constant, pushing the universe outward at a steady rate. But recent observations, including those from the James Webb Space Telescope, suggest that dark energy might not be so predictable. Some measurements indicate that its effects could vary across different regions of the universe or even change over time. If dark energy was stronger or weaker in the early universe, it could explain why these massive galaxies formed so quickly. It could also mean that different parts of the universe expanded at different rates, throwing off our calculations of cosmic distances and ages. This idea challenges the assumption that the universe has a single, uniform timeline. Instead, we might be looking at a cosmos where some regions evolved faster than others, creating a patchwork of cosmic histories. Let's take a step back and consider what this means for the bigger picture. The Big Bang Theory has been the cornerstone of cosmology for nearly a century. It's a story of a universe born in a fiery explosion, expanding and cooling over billions of years to form the galaxies, stars, and planets we see today. The CMB has been the crown jewel of this theory, a direct link to that primordial moment. But if the CMB isn't what we thought, if it's partly or even mostly the light from early galaxies, then the entire narrative is at risk. We might need to rethink the universe's age, its expansion history, and even the fundamental physics that governed its earliest moments. This isn't just a scientific debate, it's a profound existential question. What is the true story of our universe? How did it begin, and what forces shaped it into the cosmos we know today? The James Webb Space Telescope is proving to be more than just a powerful tool. It's a cosmic disruptor, forcing us to question our deepest assumptions. Its infrared eyes can peer through the dust and gas that obscure distant galaxies, revealing details that were invisible to previous telescopes like Hubble. It's showing us a universe that's stranger, more complex, and more vibrant than we ever imagined. These early galaxies, with their unexpected size and brightness, are like messages from the dawn of time, telling us that the universe was already a bustling place when it was just a fraction of its current age. And now, with this new research suggesting that their light could be mimicking the CMB, we're faced with a possibility that's both thrilling and terrifying. The evidence we've relied on to understand the universe's birth might be leading us astray. But let's not get too carried away just yet. Science thrives on skepticism, and this new idea is still a hypothesis, not a proven fact. The researchers behind this study are careful to point out that more observations are needed to confirm their findings. The James Webb Space Telescope is still collecting data, and future studies will dig deeper into the nature of these early galaxies and their contribution to the CMB. Other telescopes, both on the ground and in space, are also joining the effort, scanning the sky for clues that could either support or refute this radical idea. It's possible that the CMB is still mostly a relic of the Big Bang, with the galaxy radiation being just a minor contaminant. Or in the most extreme scenario, the CMB could be almost entirely the product of these early galaxies, forcing us to rewrite cosmology from the ground up. The emotional weight of this discovery is hard to overstate. For scientists, it's a moment of both excitement and unease. The possibility of overturning a century of cosmological wisdom is exhilarating, but it also means facing the unknown. For the rest of us, it's a reminder of how much mystery still surrounds our place in the cosmos. The universe is vast, ancient, and full of secrets, and every new discovery brings us closer to understanding it, or shows us just how much we still don't know. Imagine looking up at the night sky, knowing that the faint glow we've called the echo of creation might actually be the light of ancient galaxies shining across billions of years to reach us. It's a humbling thought, one that makes you feel both small and connected to something impossibly grand. This discovery also ties into other puzzles the James Webb Space Telescope has uncovered. For example, it's found evidence of supermassive black holes in these early galaxies, some with masses millions or even billions of times that of our Sun. These black holes, like the galaxies themselves, seem to have formed far too quickly to fit our current models. Could they be linked to the rapid formation of these massive galaxies? Did they play a role in producing the radiation that might be masquerading as the CMB? These are questions that scientists are racing to answer, and each new observation brings us closer to the truth, or deeper into the mystery. The Hubble tension, too, keeps rearing its head. The mismatch between the CMB-based expansion rate and the one measured from nearby galaxies has been a thorn in cosmology's side for over a decade. The James Webb Space Telescope's precise measurements of distant galaxies have only deepened the mystery, showing that the discrepancy is real and not just a measurement error. If the CMB is indeed contaminated by early galaxy radiation, it could explain why the two methods don't agree. The CMB might not be giving us a clear picture of the early universe, which would throw off our calculations of the Hubble constant. This possibility is both frustrating and exciting. It means we're missing a piece of the cosmic puzzle, but it also means there's a chance to discover something new, something that could reshape our understanding of the universe. As we speak, astronomers are poring over the data, running simulations and planning new observations to test this hypothesis. The James Webb Space Telescope is still in its prime, with years of discoveries ahead. Its ability to see in infrared allows it to pierce through cosmic dust and capture the light of objects that are too faint or too distant for other telescopes. Every image it sends back is a piece of the cosmic puzzle, a glimpse into a universe that's proving to be far more complex than we ever imagined. The idea that the CMB might not be the pure signal of the Big Bang is just one of many shocks it's delivered, but it's one of the most profound. It's forcing us to question not just how the universe evolved, but how we know what we know. The implications of this discovery ripple far beyond the scientific community. For anyone who's ever looked up at the stars and wondered about our place in the cosmos, this is a moment to pause and reflect. The universe is telling us a story, but it's not the one we expected. It's a story of rapid creation, of massive galaxies springing to life in a cosmic blink, of a signal we thought was the echo of the Big Bang, but might be something else entirely. It's a story that challenges our assumptions and invites us to embrace the unknown. The James Webb Space Telescope is our guide in this journey, a beacon illuminating the darkest corners of the cosmos. And with every new discovery, it's reminding us that the universe is far stranger, far more wondrous than we ever dared to dream. This isn't the end of the story. It's just the beginning. The James Webb Space Telescope will continue to scan the heavens, searching for answers to questions we haven't even thought to ask. Will it confirm that the CMB is a mix of Big Bang light and galaxy radiation? Will it solve the Hubble tension once and for all? Or will it uncover even more mysteries, forcing us to rethink everything we thought we knew? Only time will tell, but one thing is certain. We're living in a golden age of cosmology, where every new observation brings us closer to the truth about our universe, or reveals just how much we still have to learn. The emotional impact of this moment can't be overstated. It's a reminder of how far we've come, from ancient humans gazing at the stars to building telescopes that can peer back 13.5 billion years. It's a testament to our curiosity, our drive to understand the cosmos, and our willingness to question even our most cherished beliefs. The idea that the CMB might not be the Big Bang's echo is both unsettling and thrilling. It's unsettling because it challenges a century of scientific consensus, but it's thrilling because it opens the door to new possibilities, new physics, and new stories about the universe's birth. So what does this mean for you, the viewer? It means you're witnessing history in the making. You're part of a moment when humanity is rewriting its understanding of the cosmos. The James Webb Space Telescope isn't just a machine, it's a window into the past, a tool that's showing us the universe as it was when it was young and wild. These discoveries are a call to wonder, to question, and to dream. They remind us that the universe is full of surprises, and that every answer we find only leads to more questions. If this idea about the CMB holds true, it could change everything, not just our science, but our sense of who we are and where we come from. We're not done yet. The James Webb Space Telescope is still out there orbiting the Sun 1 million miles from Earth, capturing light from the edge of time. Its discoveries are just beginning to reshape our understanding of the cosmos, and this latest revelation about the CMB is one of the most profound yet. It's a reminder that the universe is a place of mystery, of beauty, and of endless possibility. So let's keep looking up, keep questioning, and keep exploring. The cosmos is calling, and the James Webb Space Telescope is leading the way. If this journey through the cosmos has left you awestruck, let us know your thoughts in the comments. What do you think about the possibility that the CMB isn't what we thought? Are you excited by the idea of a universe that's even more mysterious than we imagined? Your voice matters, and we'd love to hear from you. If you want to support our mission to bring you more mind-blowing discoveries, consider grabbing one of our t-shirts or contributing through Super Thanks. Your support keeps this cosmic adventure alive. Thank you for joining us on this incredible journey through the stars.